All right, welcome everybody. We are live, and I hope you're having a good day so far. Um, a very interesting topic that I want to talk about today: large language models and data, and the overarching umbrella category of so-called artificial intelligence. I think this is one of the biggest issues of our time, and I'm trying to get this issue right. I'm trying to be correct on the AI question, and it's a very nuanced topic. And I think I look around and I'm like, wow, everybody's getting this so wrong. And I don't claim to have all the answers. I'm not claiming to have it totally figured out. Far from it. But I see a lot of people just totally uh, getting it wrong on both sides, the pro AI people and the anti AI people. And I think we need to really put a lot of thought into this and start laying the groundwork for actually productive, beneficial uses of this technology. So, first things first, the more I look into this technology, the more I play around with it and try to build from scratch and utilize the state of the art models and the base models and do fine tuning and such, the more I see that one of the most important aspects is data and knowledge. And there are so many different sources of data and knowledge, or maybe we should just say information, because until we really put it to the test, we can't call it knowledge. But there sure are a lot of claims being made out there, right? We've covered in the past websites like Anna's Archive, annas-archive.org, with tons and tons of books, a huge open library. And then there's the website Sci-Hub, which has tons and tons of scientific papers, or so-called scientific papers. And then, of course, there's Wikipedia, there's all the content on the internet, all the videos on the internet, and so much more than that. But there's no shortage of information. And then there's also AI generated content, which can be good or bad. And there is the possibility in that latter category of being able to extract somewhat decent information initially before they close up all the doors. So we can start kind of archiving that and siphoning off as much information as possible before we figure out what to do with it. And I'm seeing that this data aspect is crucial. It is super, super critical, super important, because the models will continue to improve. Probably. We're going to get into the open source versus the closed source side of this discussion. It's very interesting. I think that's one of the biggest factors at play here. Is they're trying to stifle the development of open source, independent, let's call them, models that people can just download, train to their liking, and utilize. We'll get into that though. But data is key. So if you don't have, at this point, way more data that you can physically, manually process, I think you're falling behind. People should really start piling up and accruing as much data as possible, preferably in text format on your computer. Buy hard drives, fill them up with data. That's my advice. And beyond that, the aspect of these language models is super interesting. They're actually passing a bill in California to try to scare people away from developing their own models to compete with the likes of Facebook and Google and, of course, OpenAI. So that makes me think, especially looking at the people behind it, that makes me think that that's exactly what we should be doing. Developing state-of-the-art models, learning the technologies backwards and forwards, learning neural networks, learning transformers, learning BERT, learning, there's a whole bunch of them, a bunch of regression models. There's another one I was going to mention, but we'll cover it, hopefully. It's a big topic here. Oh, diffusion models are very interesting as well. Those are the ones that people are using to make music or make artwork. And of course, there's big controversies about the morality of sites like Udio or Suno, which people are saying, oh, they're training on all this copyrighted music and they're just ripping off the musicians and people are going to get into copyright trouble. All that might be true. But I'm just looking at the technology in and of itself has proven itself to be extremely important and valuable. And ultimately, what this channel is about and what I'm about is seeking the truth and distributing it. And I see these technologies as both a blessing and a curse in that regard. And I see it moving more towards the curse end of the spectrum. So let's dive in because there's so much to cover here. So I saw this chart. This is pretty interesting. Closed source versus open weight models. I wish they had used a different y-axis here. This is the ARENA ELO score. I'm not even sure if it's technically an acronym. We looked this up the other day. It's based off this major figure in the chess community who came up with this way to score players based off their results and who beats who. And really, this is relative. As far as I can tell, the ELO score is relative to one another. So maybe I'm misinterpreting this, but it does seem to me like this is not a great way to measure so-called intelligence, because all that I think I should really look into this metric more. But there is some gray area about what this actually means, because a lot of this could just be relative scores. How well is the closed source doing relative to open source? Each model relative to the other models. But what we see here is, while closed source is definitely winning, and that makes sense because there's so much money to be made here, especially at the corporate and enterprise level, that these endeavors like OpenAI can just raise tons of money, spin up these huge clusters of GPUs, which essentially is just one massive computer. And they can systematically increase their, they can use this money also to buy data, to label the data, to go through the data, figure out what's the best data, throw out the bad data. Of course, they'll also be gatekeeping the information, throwing out the data they don't want you to see, filling it up with propaganda and things they do want you to see, et cetera, et cetera. But I just think this is such an interesting, crucial part of our life at this point. And what I feel drawn to doing is figuring out how we can leverage each and every aspect here, from building models from scratch to leveraging these open source models that get put out. Now, I am very concerned that we have companies like Facebook leading the charge as far as the so-called open source models. And they are open source. They give you actually, I don't know if you could say open source, because technically the source is all the data that they feed into it, right? And then also the model architecture that can accommodate and learn from the data. And they will tell you the architecture. We do know the architecture. For example, we have this interesting publication that came out a few days ago about Llama 3 from scratch. So Llama 3 is the latest iteration of Facebook's large language model that they've been releasing. And this person went through and actually figured it all out to the matrix multiplication level. So as far as I can tell here, and I should really go through this more here to understand exactly what's going on here. But as far as I can tell, the architecture is known for many of these models, minus, of course, the closed source models like Anthropic's Opus and ChatGPT. But I do think there's still a lot that we can glean from the closed source models. And I think at some point these are going to be so powerful, but they'll also be castrated. And it's going to really prevent us doing certain lines of research. And they'll help our enemies doing their research, so-called research, aka propaganda. But I also see a future where people are so afraid to get banned off GPT-4, or whatever the number is at the time, that people will toe the party lines, which I find very disturbing. Similar to YouTube. I think YouTube is a great analog here. So to people knocking artificial intelligence, to me, that's like knocking a video hosting site back in the day when YouTube was first popping up and people were like, wow, we can actually share videos and people can post their videos and get videos. And then somebody coming along saying, no, we should shut down and stop all video hosting sites without like any good explanation. Now, has video hosting done more harm to the human race than good? I would argue yes. But I think that's the problem there is the establishment and what it incentivizes and what it tries to, quote, optimize for with its recommendation algorithms and its banning censorship algorithms, etc. But what was the problem with YouTube? This analog I want to draw with YouTube. What was the problem with YouTube? Well, they undercut everybody else in the game. They did fewer advertisements, at least at first. They did, it was basically free to upload videos, free to watch videos, and nobody else could compete. They were just hemorrhaging money in order to gain market share. And what did that do? That gave them the upper hand when it came time to drop the ban hammer and censor everybody they didn't like. And they could give people checks and be like, oh, hey, good videos. Here's some checks. Here's your share of the advertisements. But what did that actually do? Well, it's just like the Skinner box, operant conditioning, where they say, oh, well, here's your reward. Here's your positive stimulus. Oh, well, you did something we didn't like. Well, we're going to demonetize you. And maybe if you're on, really good behavior for the next few months, you can try to apply again. So using positive and negative reinforcement, they're able to control huge swaths of the population. And then also the recommender algorithms come into play. And everybody at this point is basically just fish in the barrel when they open up YouTube and they start scrolling through all these signals that are being shot into their heads. And when they think they make a choice to click a video, maybe that choice was made for them. And maybe it's actually going to be destructive to their psyche. That's what I would argue. But what happened over, I think we just kind of talked about what happened over time. One of the biggest book burnings ever on YouTube, right? And I see OpenAI going in a very similar direction, but they're not there yet. So one mistake is I think a lot of us, when we got addicted to YouTube back in the day and we saw the immense value and we were finding all these rabbit holes and going down and figuring stuff out about the world we never knew, we started to project what could happen into the future at that trajectory. And we started inviting our friends and family and telling everyone, hey, YouTube is so awesome. Everyone should get on YouTube. And more people got on there. More and more people got addicted. They got more and more market share. We put all of our eggs in that one basket. That was the problem we made. And I don't think there was anything wrong with us posting videos onto YouTube back in the day, because people were finding it. Cats were getting out of the bag, so to speak. We weren't having to pay for hosting. We weren't having to sit through advertisements. It made sense at the time, but it was a trap. But it was also, you could use it as like one arm of a strategy, but a lot of people made the mistake of using it as the whole of their strategy for content distribution. And that was a huge mistake. I think we can all agree in hindsight. So the real answer is for us to build parallel systems and to also use YouTube, or in this case, OpenAI, when it makes sense to. And a lot of times it does make sense. Like, for example, I've been doing a lot of coding, seeing these models get better and better and better. I'm like, okay, we need to start building frameworks to harness this technology and leverage this technology and to start siphoning off as much of this information. If we can find channels, just like on YouTube, you can find channels that are valuable. There's a lot of garbage channels, but just like on YouTube, OpenAI, you can find channels of interest. For me, it's a huge boon for programming. You can just give it an assignment. Like, you can't build like a huge 1,000,000-line app all in one go. You can't just say, hey, OpenAI, I'm trying to build another YouTube. Can you give me all the code? But if you break it down into its component parts and you start chipping away at it, it can certainly do it across, 1,000, 1,000,000 requests, whatever. And that's what's interesting to me, is it's clearly valuable. As somebody who's a programmer myself, ever since I was a kid, I was fascinated in programming computers. It's a huge help already on GPT-4. And this new model, I also want to comment on GPT-4o because I've been using it a lot more. It's extremely helpful. GPT-4o, I find way more helpful than GPT-4. It's way faster. When you switch back to GPT-4, it's like, keep having to look at my watch and I get bored because it's like taking forever to print out the code. And I'm like, okay, I'm going to go to a different tab, and then I forget about it. And 4o, while it has some mistakes and it, I don't know if it's just overloaded. Sometimes it just bugs out and weird stuff happens. But all in all, extremely helpful and extremely fast in a lot of realms, just like YouTube back in the day. So I hope I'm being very, very clear here in what I'm saying about AI. This is the nuance that I think we need to bring to this discussion. For example, the other day, I'm kind of jumping around, but let me just show you something I was doing the other day. So the other day I was building neural networks from scratch, and I'll show you that in a second here, unless I forget. But very interesting to do it from scratch and to actually see all the weights and the biases and to actually plot them out. Let me see if I can show you that screen. Plot them out and see like the architecture of the models. And for example, this was a training round that I did where I iteratively tried larger and larger models, more complex models. I played around with what are called the hyperparameters. For example, the learning rate, the batch size in this case. And the way this training worked is I kept the same data set and I would see if I could beat my best trained model. And I would just do thousands and thousands of model training runs. And whenever I got a new best, that became obviously the thing to beat. And so you can see over here, loss is how we measure. And this is, by the way, loss on the validation set. So this is data that it hadn't seen. That's a key thing when you're training a language model. You don't just want to, you don't want to throw all your data at the model and train with it, because then you have no way to actually assess how good it is, because there's no data that you haven't trained on that you can test it on. So you want to save a little bit to test on. And loss is just the measurement of how well it's doing. You want a low loss score. And there are some really cool algorithms that basically work by when it reaches the end, it sees how well it does. So there's like an equation that applies to each of these nodes, how it calculates the score as it moves through. It takes the input node on the left. So right here, this gets fed a value. For this example here, there are 3 values that feed into this neural network. So these are just the inputs. So I could probably show you that here. Got so many files open, I've got to switch over. Basically, I'll just explain it. I have x1, x2, x3, and then y. So I have 4 columns in my CSV file. And the goal is to guess the y from the x1, x2, and x3. And this example is pretty much linear regression plus some noise. And so this is, let's say this is x1 up here. The way the calculation works for the next node in the series is it takes the input times the weight plus any bias. So if I turn the biases on, each of these has a certain adjustment factor that gets added, or if it's negative, subtracted kind of. I mean, it's still added, but it goes down. And then it passes that new value along. And then there's also something called an activation function, which can further shape the values as they flow through. But it's a real simple equation as far as each node, what it passes along based on what it receives and what its bias is and what the weights are, etc. So what's cool is I've just been playing around trying to understand, okay, how many different layers do we need? How many different nodes or neurons do we need? And what ultimately is dictating how effective these models are. And then I learned, okay, well, actually there's a whole bunch more ways to do regression. This is a regression task. You can see everything's feeding into one value at the end. So a number is going to pop out the other side of this based on all those little calculations using the weights, these lines, the biases, which are applied to each node. They all get summed together, fly out the other side, and that's our output. And the goal is to get, and that's our y, by the way. So x1, x2, x3, and y. We're trying to get y and trying to train this model to predict y as well as possible. And there's other types of neural networks that we can do. There's ones that will put things into buckets. So if you have 5 buckets or 5 categories that you're trying to put each text into, or each series of features into, the way that would work is there'd be 5 output nodes instead of 1, And the one that has the largest value is the bucket that it goes into. Each one correlates to a bucket. So I find this to be a very interesting new technology. It's actually not very new. I think it's been around for decades at this point. But now we're starting to see how powerful these things can be. We're seeing things like ideogram, which is kind of like Midjourney, but can spell out text. We'll throw Midjourney in there as well. We're seeing things like Udio and Stable Diffusion and Suno and ChatGPT. We're starting to see the fruits of these machine learning researchers' labor over the decades. And it's proving to be an extremely valuable technology. And so that's why we're seeing at this point bills like this, SB 1047 out of California. Safe and secure innovation for frontier artificial intelligence models acts. And so what they're trying to do is stifle? My apologies for the lack of vocabulary, but they're trying to throw a wet blanket onto the open machine learning research. And they're trying to scare people with threats of huge fine or jail time or whatever. I mean, I haven't really gone through the whole bill. I can see that people are really freaking out about this. According to Chris here, SB 1047 creates an unaccountable agency that can refer model developers for charges that lead to jail time and is coming up for a vote in the California Senate. Yeah, recently, if we go to votes here, and this, by the way, is from Scott Wiener, who you might know, this evil politician, I would go as far as saying, in California, with a terrible track record. You've probably heard of him. Terrible track record. And this should tell us everything we need to know about what's going on here. Now, I can see why people would be upset with ChatGPT and Tesla and everyone trying to steal jobs and automate away the workforce and stuff. I'm against that as well. But I'm not against mathematics. I'm not against programming. Like, I think that's idiotic. I mean, that's straight out of Orwell. People telling me, oh, Tim, don't say 2 + 2 = 4. We're supposed to be ignorant. We're not supposed to know what 2 + 2 equals. We should stop math. So I'm getting kind of sick of it. And also, we can kind of see where they're going with this. They're going to have some sort of a terror FF and blame it on some open source artificial intelligence model. Say we need to crack down on this. We need to regulate mathematics. We need to peer into everybody's computers and track all the GPUs that are going out there. And I'm against this. I think that we need to start stockpiling. Those who can afford it and are interested should start buying CPUs and build clusters and figure out how they work and how you can leverage them. Put our heads together, put our wits together, all of our GPUs together, and figure out how we can apply this in a way that serves and suits us. So let's see. This is the latest vote here from 5 days ago. It passed the Senate Appropriations Committee. So with that in mind, let's turn back to this chart here. Well, actually, I was going to show you something here. So I looked into other regression models because I'm like, okay, this is pretty cool. I've got that under my belt, or whatever the term is. And I have a fairly rudimentary way of building neural networks and training them iteratively and doing what's called hyperparameter tuning, which is changing all these little knobs in addition to all these weights and the biases within the network to iteratively find the best solution using algorithms like, let me go back to this because that's what I was going to say. So the data flows through and it tries to guess the best Y value in this case. And based on how far it gets off the Y value and how far each of these nodes get off, I don't know the exact details, but it does calculus called gradient descent. And there's another algorithm called backpropagation because it goes all the way through normally, like it does when it's making predictions. And then it sees how well it did, and then it tries to adjust the knobs in a direction that minimizes the loss, aka makes the prediction better. The problem, though, is there's this issue when you're seeking the minimum, where you have local minima. Let me see if I can find like a little picture of this. Okay, that's probably the better way to search it. Local versus absolute minimum. So the loss curve, which basically takes into account with all the dimensions that we're playing with, which are a lot. The loss curve, which we can just kind of visualize in 2 or 3 dimensions. Let's look at it in 2 dimensions here. Say this is our loss curve, and we're trying to get it as low as possible, meaning we're guessing that y value as best we can. The problem here is that backpropagation and gradient descent will move in the direction. So if it starts here, it just randomly picks a value that starts here on the loss curve. It's like, okay, I need to go this way. I need to go left, which is actually, we can see, looking at the bird's eye view here, that's the wrong way to go. But it seems like that's the right way to go. So we go down, we go down, we go down, we go down. And then it starts going up again. We're like, oh, wait, this is the best we can find. We tap out and we say that's the best trained model. The problem is, and we had this with each of these networks that we trained on the way to this last one here with the lowest loss function, or loss value. Those are all local minima. And there's going to be a lot of them. The more dimensions you have, the more local minima. So that was a mistake I made the other day, is I thought that gradient descent, although I did think I mentioned something about the local minima, you can't just assume that these 2 algorithms, backpropagation and gradient descent, are going to find the absolute minimum. There's a number of ways to do this called hyperparameter tuning. I think there's something called grid search, etc. But for me, one thing that makes sense is just randomly trying different values. So in this case, you might start here. You might start here. Go back to that chart. You might start here, 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 just all around, just picking random points. And then you seek towards the best solution. And that should help us find all the local minimum and ultimately the absolute minimum, the best possibly trained network. And a lot of this is dependent on the data that we have. Because if we have bad data or just less than perfect data, we're not going to get the best trained model. But what's interesting is this doesn't, regression, a lot of people are like probably scratching their heads like, Tim, what are you talking about? I don't need to do any regression. I don't need to predict any values. I don't need to solve any patterns. I don't need to find patterns in data. Some people might say, wow, this is exactly what I was looking for. But depending on what you do throughout your day, different parts of this may or may not be interesting to you. But I'm just pointing out, these are the technologies, and we can build things from scratch and start working our way up to something closer to a ChatGPT, which is called a large language model. And the acronym GPT stands for Generative Pre-trained Transformers. Also, this other one that I'm really amazed by recently, called BERT, is also utilizing transformers. So transformers is a key technology, and it starts getting more advanced, which is good because this is a very, going back to this chart here, very rudimentary way of doing this, where we kind of build this abstract data structure that has all these different tunable parameters and these different algorithms that we can utilize to set them to the most opportune points. But as we make more and more complex and functional and capable architectures, then the solutions are going to get better and better, and the capabilities better and better. BERT is amazing. I'm really blown away by BERT. BERT differs from ChatGPT in that BERT doesn't actually do any text generation. But ChatGPT, all ChatGPT does is text generation. So I put them in 2 different categories. They do have some overlap. You can do something like a text classification task using both of them. And I've actually found better performance with BERT. Now, that might not always be the case, but I think BERT is an extremely interesting technology that we have. It has 110 million parameters in the base model. And it can what I use it mostly for is classification tasks. To put this into context, if I go back to this chart here, the neural network page, if we, I have a calculator here that we can look at. So if I put this in here, 256, well, actually, we take this 256 off. So 3 input nodes, 1 output node, 3 hidden layers with 128, 64, and 32 neurons, respectively. Total trainable parameters, 10,881. If we throw on this additional larger layer on the left, it goes up to 44,289. And if I click here, I think it takes a second to load. Oh, there it goes. You can see it's a much bigger model. Now, the pattern here you can probably see is that there's half as many nodes in each successive hidden layer. That's just something that I kept encountering in the literature, which kind of makes sense to me. But it doesn't have to be that way. You could have the same number in all the layers. You could have more in the later layers, whatever. But the point is, this model here, which seems pretty complex when you look at it, has 44,000 trainable parameters. But BERT, on the other hand, which is a pre-trained model, trained on English, has, 110 million parameters. So you're leveraging a much more capable model. You don't have to train it from scratch. All you have to do is what's called fine-tuning, training it with your own data set, which is something that we can do, by the way, we'll talk about this in a second, with any open, most open weight and bias models. Say, for example, Llama 3. There's a great guide here. I'm going to look through this a little bit with you in a second. Fine-tune Llama 3 with ORPO on mlebon.github.io blog. So this is something else that I want to explore in the future. I'll show you how this works and the type of data that it consumes and how it improves the performance in the direction that you want to improve it. But I also think we should be exploring, okay, how do we train a GPT type model from scratch? Maybe we can utilize this repository, Llama 3 from scratch. Still trying to understand exactly I'm not sure if actually this is exactly what we need. Probably not. But I'm interested in seeing what we can do in regards to training from scratch. In addition to if somebody comes along with a trained model, which in this case Meta, the Facebook company, is putting out the most capable models at this point. And a note on that, they've put out most recently, as you can see in this chart, Llama 3, but only 2 of the 3 Llama 3 models have been released. They say they're also training their third model, which is a massive 400 billion parameters. And what's important to note here is the cost it takes to train one of those models puts it well outside of the reach of most of us. Which I think, let's talk about this. I think a lot of this, and this chart is good to have up on the screen at this point because it's closed source versus open weight models. I think a lot of what they're doing at this point is trying to prevent people from figuring this technology out themselves. And one of the best ways for them to do this is to prevent money from flowing into anybody actually figuring out the technology for the people, by the people. Which makes me think that's exactly what we need to do. So it takes a lot of money to train one of these models. I mean, I don't know exactly how much OpenAI is spending, but just they have tons and tons of GPUs. And Meta as well. So it almost seems like an impossible hill to climb to even compete with these people. Now, the problem that they have is they have to peddle lies and propaganda and be a total disappointment for everybody. who consumes their technologies eventually will be very disappointed in them, just like I would say most people are very disappointed in YouTube at this point. Whereas back in the early days, people loved YouTube, right? And then they got the market share. All the small competitors couldn't compete, so nobody even tried. And actually, I think probably people did try, but why would people go to a site that was running a bunch of ads, that was charging people to host videos, when YouTube would do it for free? It's like, oh, you guys suck. YouTube is much better. Little did people know that those alternatives were actually the saving grace. So that's the problem with the establishment models, is that they're going to have to become extremely censorious. I would say they already are to some extent, but it's going to become much more apparent. And they're going to have to use regulatory capture. I mean, they're all in the same team. It's not really regulatory capture. They're just a bunch of evil puppets of oligarchs in both the corporate and the governmental world. But they're going to have to use the laws they can pass with these government puppets to protect they basically pull the ladder up behind themselves. But I think at this point we can safely say that these technologies have proven to be extremely game-changing. So diffusion models are also very interesting. I know I'm jumping all around, but I think we should really figure as much of this out as we can. And there's a lot of open source tools that we can leverage. And then we can build things that don't exist. And things like ChatGPT can actually help us do this. That was the other thing I was going to show, but I can't finish my thoughts at this. I mean, there's a lot to cover. It's fine. So diffusion models are very interesting because they train the model how to remove noise. Remove noise. And so if you ever see the, let me see if I can find like a GIF of this. GIF of stable diffusion removing noise. So based off the prompt, okay, here we go. So this is, at the beginning, something that has a ton of noise. And then what they're doing is, based off the prompt, they, quote, remove the noise in the direction of the text, which in this case is a cat, or whatever the person typed in. And so I know people hate me when I ask ChatGPT questions, which is very telling to me. It's like, are you guys not using this technology? That's crazy to me. How do diffusion models work, and how are they trained? It's actually like a really amazing technology. And if you're not using it, I feel like you're falling behind. And I think if we're not building alternatives, we're falling behind. And certainly everybody's falling behind at this point. We're up against very powerful players who have clearly seen the potential here and are worried about us seeing the potential and applying this in a way that is counter to their objectives and their goals. So diffusion models are inspired by the physical process of diffusion, which describes how particles like molecules spread out over time. In a context of generative models, diffusion can be thought of as a process that adds noise to data, step by step, until the data turns into pure noise. The key idea is to reverse this process to generate data from noise. So they take a bunch of images that are labeled. So they have a bunch of pictures of cats. They must, in order to, at some point, generate a cat from noise. And then they add a little noise, and then they train the model how to remove that noise. So they have what's called the forward process and the reverse process to add and remove noise or generate data, respectively. So the forward process is adding noise. The model starts with real data, like an image, and gradually adds noise to it through a series of steps. At each step, the model adds a small amount of Gaussian noise, making the data progressively noisier until it's indistinguishable from random noise. This transformation is designed such that it's mathematically well-defined and reversible. Then in the second stage, the reverse process, and this is where it comes into play, because then once they have this technique for removing noise, they can generate something pure noise and say, okay, remove the noise until you get a cat, or whatever the person typed into the box. Same with the song. Instead of an image file filled with noise, it's an audio file filled with noise. And then whatever the person types in the box, they're removing the noise until it's as close as they can get to what the person typed into the box. It's a fascinating concept. It could also be applied to other realms, although I think those are the most two obvious ones. I think you could probably use it for text synthesis as well. So let's read this section here. The core of a diffusion model is the reverse process. The model learns to convert noise back into data. Starting with a sample of pure noise, the model iteratively predicts the noise that was added at each step of the forward process and removes it. This step-by-step denoising happens over the same number of steps as the noising process, gradually reconstructing the data from the noise until a clean sample is obtained. All right, so for example, there's something called the diffusers library, Hugging Face, I think. Now, I'm not sure if this is true, if it's actually the state-of-the-art library as it claims, but it says it can do images, audio, and even 3D structures of molecules, or whatever. That's kind of not really my interest at this point, but the images and audio is interesting. And it's not really at the top of my list as far as like what I want to achieve. But I think if we learn the tools and then we have them in our arsenal, then whatever problems pop up, we can be like, oh, maybe we can make a diffusion model for that, or maybe we can do a regression model for that, or maybe we can do a transformer-based model. We can use BERT, custom-train BERT, or we can fine-tune Llama 3, et cetera, et cetera. And ultimately, we need to be building our own base models, free of all the propaganda that are being baked in by these establishment players. So going back to regression, which I find to be a very interesting problem, I was looking into, okay, what are some alternatives? Because I started just asking questions. I think that's a great thing to do. And so I was like, okay, I came up with this, it's called PyTorch, which is something that allows you to do a bunch of machine learning type tasks. There's also something called scikit-learn. And I built this neural network that I just showed you. And it was doing pretty good predictions. And so I said, okay, what other options are there for regression tasks? But you could fill in the blank, whatever type of task you're wanting. It's good to have a list of like, okay, what are all the models that are out there, the open source models that I can leverage for this? And for example, let me see if I can find that. I've got a lot of random files, or not random files, but I'm juggling a lot of files at this point. But what I did is, see if I can find it. Basically, I made a list of all these different alternatives that I found to just a straight up neural network. That's called a feed forward neural network, what we covered previously. And so my question was, what if these other models are superior? Because they probably are. Like a feed forward neural network is something that's been around for decades. I want to see what else there is. And what's great about ChatGPT is we can actually build prototypes and actually put things to the test and have working code in just a matter of minutes. That's what I want to show here. This is one of my favorite use cases for ChatGPT. Okay, so yeah, this was just a little worksheet or a list that I was making with the help of ChatGPT, trying to find other models that I could use for regression. And then I wrote a spec sheet, basically that says, write me a series of general Python classes and a runner script to solve regression tasks. Now we could put something else in here. Say you're trying to generate music or generate artwork, whatever you're trying to do. And those might be kind of hard ones because it takes a lot of training and there's a lot of competition already that you could just leverage the competition. But I think figuring this technology out and actually understanding it will pay dividends. It's never a bad idea to increase our knowledge in our tool set. So, I was just kind of playing this out with the regression side of things because one problem that I've been having is BERT is amazing. This library called BERT, or it's a model from Google, which you can train to tell you, okay, basically you define how many categories you want. Could be 2. You could just be saying yes or no for each. Or you could have 10 categories or however many classes you want to put things into. And what we're doing is classifying text. The problem I had is BERT doesn't do well with numbers. It does great with text of moderate length or short length. But as soon as you want to actually include numbers, which can be very, very telling, right? If you have average user rating or something, or on YouTube, how many thumbs up and how many thumbs down it has, or on Twitter, how many hearts does it have? How many retweets does it have? You know, all these different so-called features, right? You have text features and you have categorical features and you have numerical features. But BERT doesn't do very well with numerical features or even categorical features. So my question is, what if we could utilize BERT for some aspects, such as classifying text in a way that we think will be useful for a model to leverage? Then we have some other numbers. So let's say, for example, you want to save time and you have a bunch of tweets that everybody you follow has been putting out, and you just want to see the most interesting ones. Well, maybe you'd want to feed the text through BERT, a BERT model that you've trained on your preferences to tell you yes or no, are you going to be interested in a tweet based off the text itself. But then you also want to feed into the model how many likes it has, how many retweets it has, how many bookmarks is another number you could leverage on Twitter. Well, all you'd have to do is combine BERT with a regression model, where the BERT is going to spit out some numbers. In this case, the percentage that you'll say, yes, I'm interested, or no, I'm not interested, just based off the text alone. And then that feeds in, along with these other numbers, into a regression model, like this one on the thumbnail that we were looking at earlier. So that's kind of why I'm looking at regression at the moment, because it helps me extend the functionality of BERT. So, and then there's also other types of models that are interesting, like so-called recommender systems I find fascinating, especially because I have a website called groupdiscover.com. Awesome website. I hope you'll check it out and sign up, support the show. There's a 50% off discount with the coupon code ANTIPOISON. But one thing that I've always really wanted to do with that website is give people like the best possible suggestions, because we have over 20,000 awesome videos in there. But different people have different tastes and different preferences. So right now I have an algorithm that uses basically the IMDb approach to top movies. And the way it works is you don't want to have something with just 1 5-star rating. That's the way ratings work on this website, my Group Discover website. 1 through 5 stars, everybody can rate each video. And the way it works right now is it'll suggest videos you haven't seen yet that get the best rating by the whole group. So it's a really non-invasive way. I'll never do anything invasive or anything that flies in the face of privacy or anything like that. But the way the algorithm works is we don't want to have a video with just 1 5-star rating go above something with 1,000 5-star ratings and 1 4-star rating. Right? Technically, the average rating is higher for the 1 5-star. But the problem is, at least according to how I want to design my algorithm, I want that video with, I forgot how many ratings I said earlier, but let's say 1,000 5-star ratings and 1 4-star rating. I want that to be first. So the best algorithm that I could find, the simplest algorithm, is using what I call ghost votes. So you take the average rating across all the videos in the site, and you put some number of those ratings, say 10 of those ratings. Immediately, if we take the average, say 4.75, 10 4.75 ratings in that 1 5-star rating is going to be lower than 10 4.75 ratings and 1,000 5-star ratings and 1 4-star rating. So that's a quick little hack to making a great recommender system. But we could do better than that. So that's another thing I want to play around with and see what we can do and what models there are out there to help us. But trying to see, so that's why I'm interested in regression. not for the recommender systems, but for extending BERT with numerical features. So basically what I did is I found this list of model types. And I'm like, okay, I could go through, basically I wanted to go through and make a working example using ChatGPT to do the legwork for me of each of these. And I had some example data sets already laying around. So that's what I got into here. So write me a series of general Python classes in a runner script to solve regression tasks using, and this is the fill in the blank where I put the model type from my list, where I have a number of numerical features and I'm trying to predict 1+ target numerical values. Solve these subproblems as well as possible. So I tried to kind of guide its hand here. Basically, though, I'm looking to do regression tasks using model whatever. So we have this list here. Scikit learns linear regression, Scikit learns ridge regression, its lasso regression, support vector regression, decision trees, random forests, gradient boosting, elastic net, ADA boost, XGBoost, light GBM, cat boost, and TensorFlow Keras, which is pretty similar to what I already have, which is PyTorch for neural networks. That's what I was looking at earlier. So basically I just wrote up a spec sheet, and the key part here is I wanted to give it some concrete examples. So I have this one here, x1, x2, x3, and y. And this one I believe is as close as possible to perfectly linear regression. So no noise added. Then this task 3 down here, regression data 2 has some noise mixed in, but otherwise is linear. And then regression data 1 is just, I made ChatGPT make some average or some dummy data that I could build models off of. And then ultimately I'll put this to the test with some real useful information that's not just canned. And then as soon as I ran this a bunch of times, I just opened new tabs and I pasted this in. And as soon as I ran it, I'm like, oh shoot, I've got a better example, because none of these had categories. And categories are really important. So you'll see that in this flow here. So basically, first off, it gave me them all in one file, which I actually didn't want here. So I said, break it apart. So it was kind of like the pictures of Bobby Fischer playing a bunch of games of chess against all the different opponents. That's how I felt here. We had a bunch of different conversations going with similar goals. We want code that compiles and runs and does regression tasks for us using different models. And based on the responses that each of them give, you might have to kind of nudge it in a certain direction. So it broke it apart into the different files. One problem here, though, is I can already see with the runner, it doesn't go through all of my data sets like I asked it to. But one of them, I remember I had, out of like the 7 or 8 different ones I tried, one of them gave me a pretty good go at it. And so I fed it back along with this other example that uses categories. So I think I showed this the other day in a prior stream. This was one that I also had ChatGPT help me make some data for basically training and guessing the price of a car based off of the mileage, the age, other numerical values, categorical values, like the, let's see, transmission type has sunroof is technically a categorical value, has navigation, categorical value. Now, technically, I think I put num doors as a numerical value, but the more I think about that, I would almost consider that more of a categorical thing. Like one category of cars is a 2-door, another category of cars is a 4-door. But you don't really think of like the 4 doors as like twice a 2-door. I mean, I guess technically, right? But you could break this down differently. Some of them could be put in as numerical or categorical. But the key difference here is that we're actually having categories. Like for brand, we have, I think, 12 or so different brands. Fuel type, 2. So you get the idea. I just wanted to include an example with categories. And then I found a pretty good example from a different file, a different chat, where it actually did a better job of looping through and having a more structured way of defining each of the data sets and then going through each of the different data sets. And then I said, here, continue the code. So then it started giving me these responses. I copied and pasted them into a bunch of different files, put them all into their own folders. And it's kind of an ongoing problem that I'm working on. It's just, okay, let's put these all to the test using code, and then we have working code. If any of them really shine. And I'm also just curious, like Light GBM. I've never heard of that before. Let's search Light GBM. Light Gradient Boosting Machine is a free and open source distributed gradient boosting framework for machine learning. 16,000 stars on GitHub. Never heard of it. So with programming, something else I wanted to point out, because I think that programming with ChatGPT is like a game changer. And one of the key things in programming is you don't have to reinvent the wheel. And oftentimes it's best to not reinvent the wheel. You just want to figure out what the wheel is. You want to figure out what the library is that you can leverage or what the model is that you can leverage. And that's half the battle. And then once you pick one, there's a ton of great, there's usually a bunch of great documentation on the web, and that's enough for ChatGPT to be able to speak in that language, where you're just using something that exists and has maybe millions of lines of code in it. And you just download it and you're off and running. To me, and it's going to be higher performance than anything you can sit down and build in an afternoon, even with the help of ChatGPT. So that's where I think we can really make some solid ground. Is finding the best libraries out there, finding the best models out there, then leveraging ChatGPT to help us hit the ground running with those. So let's look at some of these other ones. Like lasso regression. I've never heard of that before. So I'll put that to the test. Support vector regression. So previously what I'd have to do is really do the digging into seeing what is the best model to use before I spend time really developing it. But now we can just spin up a bunch of different working examples, try them all side by side with the same data set and see which one performs the best. So I just wanted to point that out. Like I'm super blown away by, and I think it's still in its early days, but ChatGPT 4o is the latest model that OpenAI put out. Now on really long texts, I think ChatGPT 4, just the standard 4, does better. But I've seen a lot of problems get addressed with 4o. I think probably because they're training on better and better data each time they run their model trainer. A key aspect, so the function, the performance of the model is a function basically of how good of data and how good their model architecture and training process is. Those are the big components. So again, I think we should just look and see what we can extract, what we can siphon off. And this might also be in terms of data. Can we just save off huge troves of AI-generated reports and summaries, and later we'll figure out what to do with it, kind of thing. Because we never know. It's kind of like back in the day with YouTube. Few people had the foresight to archive and download all those videos. We're like, oh, why would we download them? YouTube will store them, and then the biggest book burning ever happened, and very few people had copies. So I'm saying, why don't we make a bunch of copies? Then when they become censorious, we can just train our own models, hopefully. Speaking of training our own models, another thing I wanted to cover here is the fine work from Maxime Lebon. You can find on both MLebon, on basically MLebon on GitHub. And then you can also put, I think, /blog on here. click this link. And this fine-tune Llama 3 with ORPO. Actually, this, let me just show you this one. So I'm still working through this. I haven't really gotten too far through, but this LLM course is pretty amazing. I think the large language models are probably the most important and interesting application of AI because there's so many different types of language. For example, I've seen people who can play songs on their guitar, their piano, just by looking at like a tab sheet on the internet. And so if you trained a language model to make music in the form of a tab sheet, somebody who's, capable of playing from a tab sheet could play it. So you could just look at that as the language. It doesn't have to be English. And other languages that are super important as far as these models can synthesis and answering questions go is programming languages, as we've somewhat discussed here. So if you're looking for a good starting point, this is an amazing resource. I mean, probably better than any books out there, frankly. But one key aspect that I wanted to show is the fine-tuning section. And it seems like the latest approach that Maxime has gone with, after trying a lot of different things, obviously, is fine-tuning with ORPO. So if you click article here, there's also a Colab, which is basically an executable script that has basically everything you need. You can also run this on your own machine or up in the cloud on Colab, which I think is a Google product. But this example here uses the 8 billion parameter model. And you're basically you're spinning up a new model using this as the starting point. And then you're feeding in this type of data, which is really interesting. It's called ORPO data. So ORPO stands for one right pair only, which consists of a number of records, each with a prompt, a chosen answer, and a rejected answer. So there's some examples of this that you can find out there, but I think we need to start asking, how can we generate our own ORPOs? I don't really want anybody telling me what my preferences are, but myself. So for example here, there's an example logic problem here. In a basket, there are 20 oranges, 60 apples, and 40 bananas. If 15 pairs are added and half of the oranges were removed, what would the new ratio of oranges to apples, banana? So I've seen a lot of people like test models with this type of question, which to me, I have very little use for such a question. But I think people are trying to figure out, like, okay, how smart are these models? Can it actually reason? Can it figure things out from a complex task that it's never seen before? Which it's good to put things through their paces. But as far as like what I would want to train and do fine tuning with, this wouldn't be on my list, frankly. But I can think of a lot of things that I would want to put on my list. So it's interesting to think that with these models like Llama 3, 8 billion parameters, or Llama 3, 80 billion parameters, or their 400 billion parameter model, it's interesting to think that you get all of the weights and the biases, and you can feed more data through and do these algorithms, I think like back propagation and gradient descent, and you can tweak all those values and make it more and more your own. Now, how much can we actually tweak it? I'm not sure. It's also, what I really want to say is it's interesting that these models basically function as a database to some extent. Like there's a ton of data that's being stored in these models. And then there's always the question of, okay, what if I pass more data into it? That's what retrieval augmented generation is. It's like, okay, if you run into an issue where the model doesn't have the requisite knowledge baked in, well, what if I fed it into it as part of the input? But it's pretty amazing what's been proven in these proof of concepts as far as how much knowledge can be baked into such a model. But we can't really trust that they're going to bake the information that we want to bake into the model. Also, it seems clear that into the future, there's probably going to be the benefit if we can separate, at least, maybe not entirely, but have a huge database that sits alongside the model. And not use the model as a database, but rather have a huge data store that gets leveraged in conjunction with the model. So there's so much more to be untapped with utilizing these models. Like, it's still a really early stage in the process. But I certainly don't want to allow Meta and OpenAI to be the only ones in the game. So I don't want to spend too much time on this because it gets into the nitty gritty, but that's exactly where we need to get and delve into ultimately. But I don't think this is the best stream for it. So I'm still juggling these ideas around. And I'm wondering, why is Meta putting out these huge open source models? Kind of like we should have been wondering, why is YouTube allowing everybody to store videos on their site for free? And not running any ads. So, like, what's going on here? Seems like a trap. So I think there's a lot I still have to figure out, but I intend to. In stuff like Scott Wiener trying to pass this law in California to throw a big wet blanket over open source AI researchers, makes me think I'm on the right track here. So let's read the summary from Maxime on Twitter. The gap is widening again after OpenAI's latest release. ChatGPT 4o significantly outperforms competitors in the chatbot arena. So MMLU, that's what I was looking for. MMLU might be a more interesting thing to put on the y-axis for seeing how well these compete against each other. But a lot of it, too, is dependent on what you're trying to accomplish with the models, as far as how intelligent they are, how useful they are to you. So I'm also very interested to see, where does Llama 3 400 billion land? So Llama 3 8 billion is here. 70 billion is here. We were told that the 400 billion parameter model was on par, or maybe a little bit higher than the GPT-4 model, which would probably be around this line here, 1240. But then ChatGPT pulled out of their back pocket GPT-4o. Where will the open source or the open weight model, the 400 billion parameter model, fall in the competition? I'm not sure. I'm also not holding my breath that there's too many amazing research projects out there that can compete. There really ought to be. But it does take a lot of financial investment and a lot of data wrangling, data acquisition. Again, that's kind of one of my overarching messages here, is we need to start stockpiling as much data as possible, as much information as possible. We don't need to worry anymore about, oh, well, I don't have time to read all that. There's no way I'm going to read all that. That's not really a constraint that we need to be afraid of. Actually, the more that we acquire, the more that we'll see the need for automating the processing of it. And if that means feeding it through, whatever the largest, best open source language model and fine-tuning it, or using retrieval augmented generation and having a data store alongside the model, there's certainly already a ton that we can do with big data sets in these best models. And I'm just trying to figure out how far we can take this. I'm also trying to figure out where they're going with this. So I think one of the big aspects here is there's so much money to be made that the establishment, first of all, wants that money. And they're also afraid of any small competition getting any share of it. Because, people have different motives, right? If somebody's motive is purely just making money and serving humanity, which I don't believe OpenAI's model, I don't think that's what OpenAI is trying to do, contrary to their public statements. I think what they're trying to do is get control, get this AI situation under control for the establishment. And same with Meta, by the way. But if independent researchers were like able to actually build a competing model and say crowdfund $1 million and get as much data as possible, and maybe even crowdsource all the data acquisition tasks out there, and everyone's just like pouring through tons of data. It's just this huge worldwide people's revolution trying to build the best model possible for humanity. That would be a huge threat to the establishment. And you can see they're already like worried about that, even though I don't really see signs of that happening yet. I wish it would. But one of the key things is they have to stay ahead so that everyone just turns to them. Everyone just uses ChatGPT because it's the best thing. Just like everyone just used YouTube because it's the best. It was the best. So it's about, just edging out the competition, but not really releasing anything that's too powerful, because then any average person could just leverage the power. Also, they're doing tons of cutting edge research that they can apply behind the scenes. And I'd be shocked if they didn't. I'd be shocked if they didn't take what they're learning at Meta and OpenAI and just buy a bunch of GPUs in some private capacity, these oligarchs, and take their huge intelligence repositories, feed it through, and train their model. I'm sure they're doing that. I find that really hard to believe that they're not actually doing parallel model training to serve themselves. So there's so many things to think about and to go through, and I find it fascinating. A lot of what I'm doing here is from like a defensive posture and trying to defend against this menacing threat, because when wielded by the wrong people, super advanced AI becomes a very terrifying prospect. I'm sure we can all agree about that. And they will continue to wield it. The question is, what are we going to do? Are we just going to be fish in a barrel? Or will we, pick it up ourselves and fight back? I hope the latter. But I'll start wrapping this stream up here. If anybody has any questions in the chat, do let me know. I hope everybody's doing well out there. Also, I'm going to get my email out there, timtruth@protonmail.com. If anybody wants to collaborate on any of this, I'm still trying to figure out what are the best ways to do regression. What are the best ways to do classification? Let's figure out diffusion as well. I published a pretty good, I think it's actually really awesome, set of code on my Substack for using BERT for text classification. And I'm going to continue to try to figure out the best applications of this technology and publishing it. So make sure to follow me over there as well. And the large language models are especially important. And using them as research aids, because it's not just, I almost feel like the term large language model is lacking in terms of what I really wanted to do. What I really want to be able to do is feed in millions of books into this thing, database / intelligence, and then be able to query it and actually get like source material back that's the most relevant and interesting, and have it guide me and take me to, spin off topics and other topics that are going to help me understand what I'm going for, what I'm interested in. Like recommending new topics to me that I can explore. And of course, I also want to share it with the world and publish it and get it into some sort of a shareable file, videos, documents, etc. That's always been a key concern of mine, but also just at a selfish level, I want to understand the world and what we're where are we? What are we? What do we know about nature? What can we know about nature? Et cetera, et cetera. There's been a lot of very smart people doing a lot of research over the millennia. And so much of it has been purposefully concealed from us for a reason. And I also just get a huge sense of joy from finding a scoop and sharing it with people. So I think artificial intelligence and natural intelligence is one of the pinnacle aims of mine. You know, I've written programs since I was a kid. I've always loved reading books, watching videos. That could all be viewed as artificial intelligence. A computer program, in a sense, is artificial intelligence. If a neural network is, then a computer program is. Then a book is. A video is. Right? When you watch a video, it's artificial. It's not somebody, actual flesh being speaking to you in real time in the room, even though it kind of sounds like that if you close your eyes, right? So I don't have a problem with it, personally. And to me, I see this push where they're trying to get the population to turn on intelligence. And I feel like Winston Smith trying to be like, no, guys, 2 + 2 is 4. 2 + 2 is 4. And they're like, nope, war is peace. So I'll leave it there. Do reach out to me if you have any thoughts on this topic. timtruth@protonmail.com. And I encourage everybody, let's start, playing around with these tools. You can really easily, let me just show you this. If we go back to ChatGPT, like anybody who's on Netflix, I would just say cancel your Netflix, get a ChatGPT account. You know what I mean? Like if you have $20 that you can cut out of your budget somewhere else and just delve in to see what you can figure out with ChatGPT, I think it's a great use of time. And $20 a month is kind of very reasonable for what you can get out of this. Now, if you don't touch it at all, if you don't use it, it's not really a good deal. But let's just look at here. So let's do this way. Say I have 1,000 images that are labeled. So that's like a key term in machine learning. That just means some text is written alongside each image. Give me Python code to generate... Actually, let's do music. I think music's even more interesting than images. So say I have 1,000 songs that are labeled. Give me Python code to generate a diffusion model. Shout out to Plasma and, like the name says, just photos in the chat. Plasma says we need to make our own neural systems. Absolutely. So say I have 1,000 songs that are labeled. Give me Python code to generate a diffusion model and train it using my songs. Then give me the code to generate new songs from a text description using ChatGPT 4o, which is much faster and does pretty well. So this is for Python. This is pip install, so this is downloading other packages. Again, it's kind of going back to the don't reinvent the wheel. There's a lot of great libraries out there that you can plug into. Oh, shout out to D. Allen on YouTube. See if I'm missing anybody. Shout out to Dominic and Hempcar on Rockfin. Nobody wants to say hi on Rumble. I think I got everybody. So prepare your data set. So again, it's important to split into training and validation sets. Although I don't really understand here how validation would work when it comes to generating wave files. For like regression tasks, it makes total sense to me why we'd want to save data that hasn't been seen in the training to see how it's going to fare in the wild with unseen data. So it gives me some code. So it makes a class song data set. Has all the paths to these wave files in both the training and the validation sets. I'm not sure where the labels are here. Let's ask it. It's good to be very picky with ChatGPT. Like, follow up and be like, no, you need to redo that. You need to redo that. What's going on here? I don't understand. Explain this to me. So where are the labels being used? I want to be able to prompt by beats per minute, genre, etc. Okay, so I noticed that I didn't see this yet. Step 4. Generate song from text. Model text description. Text to feature model. Now this is interesting. This appears to be a Facebook Wave to Vec model. So there's a lot of these like models just floating around that can be tapped into. Now this looks like some sort of speech-based model. I mean, there's so much crazy stuff that's going to pop up if people get into making this and people investing in GPUs and such and putting them to use. Okay, so let's try again with my follow-up question. A song data set. So it's not exactly what I was looking for, but you get the idea. There's different features here. There's beats per minute and genre. Genre, I guess, is just going to be from a list, a number. But you can say like, okay, 0 is rock, 1 is pop or whatever. Step 4, define the diffusion model with conditional input. So it's just giving us code here. And it's probably not the best code. It's using Atom as the optimizer. It's using MSC loss as the loss function. Train, validate. So I don't have too much faith that this would be exactly what we're looking for, but by asking questions and following up, you can get to a starting point and then you have something to beat. And so we should just keep an eye out if there's technologies that we come across that are powerful that we can put to use. Because we've seen with these proof of concept sites, like in the case of music generation, that site Udio is making the rounds, the waves, and then Suno, etc. So what it's claiming is from this code, you could then prompt with this text description a calm and soothing melody with gentle rhythms. Beats per minute 120, genre 0. So I don't know. Clearly this is not what I'm looking for, but then again, it's trying to respond in like a reasonably sized request. Usually you can only expect like 100, 150 lines of code for any time you prompt it. So there's kind of the bootstrapping process where you get a good starting point and then iteratively improving it with follow-up requests. Let me just pretend like I tried this. I tried it, but the song is really bad. How do I make this better? Refine the model architecture, deeper architecture, increase the depth of your model by adding more layers, attention mechanisms. So it's still kind of using the same approach, but it's doing some more finessing and normalization and pre-processing, as it's called. But I don't know. I just don't. Let's see if there's something I'm missing here. Diff wave model. That's the saving. Where does it load the model? Okay, from transformers, import wave to vec to feature extractor. Let's just search. I think I already did, right? Wave to vec to. The abstract from the paper. We show for the first time that powerful learning representations from speech audio alone, followed by fine-tuning on transcribed speech, can outperform the best semi-supervised methods while being conceptually simpler. So it uses speech. It sounds like more like speech. Is there a wave to vec to feature extractor alternative more suited for music? They say Jukebox by OpenAI, but let's see, Music VAE. So again, not really a task that's like at the top of my list for trying to solve. There's ways that I prefer to make music than this, but it's really interesting as a technology. Diffusion models. And the two like classic examples for diffusion models would be making images or making songs or speech or videos even. So like, for example, that Sora model they claim is a diffusion model. Although for all I know, they're just fucking with people and making videos using like special effects and stuff and telling people it's a new AI model just to scare people and pass regulation. I don't know. They haven't released it for public consumption yet. All right, so we'll wrap it up there. I know I've been rambling, but I really appreciate everybody stopping by. And I'm going to keep plugging away and thinking about this. It always tells me I'm onto something when people thumb down my videos in huge numbers. Like when I tell people, don't drink your pee. Get like half thumbs down. Tell people ivermectin's clastogenic, fertility destroying, depopulation agent. Half the thumbs are down. I tell people 2 + 2 is 4 and we should learn math. Half the thumbs are down. I know I'm onto something. So I'm collecting thumbs down I'm collecting thumbs down from idiots and shill sock puppet accounts. So lay them on me. And I hope everybody has a great rest of your day.